All right, here is the review for Chapter 5, first semester quiz. It says add, subtract, or multiply the following polynomials. Make sure you write your answer in standard form. Okay. Now remember, look before you even start the problem. Notice nothing in between the parentheses. That means this is a multiplication problem. Here we have addition, and remember, the parentheses really don't matter because it's addition. You can just ignore them. Right here, we have subtraction. All right, so remember this -4 here is going to be distributed throughout the parentheses. And again here, nothing in between, so that's multiplication. Okay? So I'm going to distribute the 4 to all 3 spots. So 5 times 4 is 20, and then the x squared tags along. Don't know what happened there. Sorry, technical difficulties. X squared. And then the 4 times 3x is going to give me 12x. And the 4 times -9 is going to give me -36. Now I'm going to distribute this -x to all 3. So -x times 5, negative times positive is negative. 5 times 1, and x to the 1 times x squared is x cubed. -x times 3x, again, negative times a positive. 3 times 1, x times x is x squared. And negative times negative is positive, 9 times 1, and the x just tags along. Now, I need to look for like terms. So there's my x squareds. Here's my x's. I have just a constant. And here is my winner for the lead highest degree, -5x cubed. 20x squared minus 3x squared is 17x squared. 12x plus 9x is 21x. And the -36 at the end. Final answer. Number 2, again, we can just ignore the parentheses. So I'm just going to look for like terms. Here's my x cubes. Here's my x squareds. I have 2 constants and just this one x. So 5 plus 2 is 7. So I have 7x cubed. 8x squared plus 14x squared is 22x squared. The -9x alone just tags right there. And then -14 minus 11. You borrow $14, you borrow 11 more, you owe 25. Standard form, remember, means descending order of exponents. So in this one, notice I have a 2 out here to distribute here, here, and here, and the -4 to distribute. So 2 times 8 is 16, and then x to the 4th. Positive times a negative, 2 times 4, and the x squared just tags along. And then 2 times x is just 2x. Now distributing the -4. Again, sign number variable. Negative times a positive, 4 times 3, and the x cubed just tags along. Negative times a positive, 2 times 4 is 8, and the x squared just tags along. Negative times a negative is positive, 4 times 3 is 12, and the x just tags along. And finally, negative times positive is negative, and then 4 times 17 is 68. Now, like terms. So I have an x squared here and an x squared here, an x and an x, and that's it. So now I just look for descending order. Highest exponent is 16x to the 4th. Next is my -12x cubed. Now I'm going to join my x squareds. -8 is -16. 2x plus 12x is 14x. And the -68 just goes at the end. Final answer. So here, again, we're multiplying. it doesn't matter which way you draw it. I'd like to work backwards. I like to do the 2 times 3. So I'm going to take the 3x times each of these. So sign number variable, positive, positive, positive. 2 times 3 is 6. X squared, x to the 1 gives me x cubed. Positive times negative is negative. 3 times 5 and the x squared, x times x. And positive times positive, 3 times 4, and the x just tags along. Now I'm going to send the negative 5 in. And leave my self space to draw the lines, but you know what I'm doing. Negative times a positive is negative. 2 times 5 is 10, and the x squared tags along. Negative times negative is positive. 5 times 5, and the x tags along. And negative times positive is negative, and 4 times 5 is 20. Let's look for like terms. X squared, x and x. Here's my highest degree. So 6x cubed, negative 15x squared, negative 10x, you borrow $15, you borrow 10 more, you owe 25. 12x plus 25x is 37x, and the negative 20 just goes at the end. Final answer. Oops, I didn't preview these, but all right. Number 5, again, nothing in between, so it's going to be multiplication. It's a 3 by 3, so it doesn't matter which way I go. Going to be a lot of writing, but 3 by 3, remember, I'm going to get 9 terms. So I'm going to do x squared times each of these first. So x squared times x squared is x to the 4th. Positive times a negative, x squared times x to the 1 is x cubed. X squared times 3 is just simply 3x squared. Now I'm going to do 3x times each term. So positive times a negative, 3 times 1, x times x. Sorry, my bad. I made a mistake there. I jumped ahead. x1 times x squared is x cubed. Now, and I jumped ahead with that, sorry, this should be a plus. I'm doing 3x times x squared. Now, 3x times negative x, it will be my negative 3x squared. Sorry about that. And finally, 3x times 3 is just simply 9x. And now I'm going to clean up this 9 first. Now I'm going to take the negative 8 times all 3 terms. Negative times a positive is negative, and then it's just 8x squared. Negative times negative is positive, and that'll just be 8x. And negative times a positive is negative, which will give me 24. 8 times 3. And there are my 9 terms. Now I'm just going to look for all my cubes. Right there, and that's it. And my x squareds, I have 1, 2, 3 of them. My x to the 1, my linears are right there. And the 24 and the x fourth are singletons. They're alone. So again, here is my highest degree. So x to the 4th. 3x cubed minus 1x cubed is 2x cubed. 3x squared minus 3x squared, those actually cancel each other out. And I have this negative 8x squared down here. 9x plus 8x is 17x. And the negative 24 just at the end. All right. Number 6. Then distribute the 4 here, 2x here, and negative 3x here. So 4 times 2 is 8. That's going to be 8x cubed. 4 times negative 5 is negative 20, and it's going to be just x. 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 3x times x squared is negative 3x cubed. And negative 3x times 5 is negative 15x. My highest degree is actually both of these. So 8 minus 3 is 5x cubed. I only have 1x squared. And then I have 3 x's. So negative 20 minus 8 is negative 28. And if I subtract another 15, I get negative 43x. And that's it for that section. All right. The following are in factored form, okay? You have to know the different forms. So factored form, notice we have a single constant, we have one parentheses, and we have a parentheses squared, which really means x plus 6, x plus 6. State the degree, type of function, and leading coefficient. So we basically just look at our x's. This is x to the 1. This is x squared. So our degree is going to be 3, which makes it cubic. And the lead coefficient will be this 4 right here. Now remember, that's the shortcut. If you need to, you could FOIL this out, and you'd get x squared plus 12x plus 36, and then multiply the x plus 3 times that. But when you do that, x times x squared is just going to give you x cubed. And then when you distribute the 4 at the end, you'll get 4x cubed. So there's no reason to do all that work if you can just see the shortcuts. Okay, number 8. Again, this is going to make that x squared. Then we have x to the 1, x to the 1, so that's going to be 4, which makes this a quartic, like quarter, 4 quarters in a dollar. And the lead coefficient is this negative 2 right here. All right, determine if it's a polynomial. If it is, fill in the information. If not, explain why it is not. Okay, so number 9. It is a polynomial. It is not in standard form because notice the 4 is not first. So we put this first, then the 5x cubed, then the 3. The leading coefficient now becomes negative 1. Now, the most common mistake here is to say lead coefficient is 5. You have to put it in order first. It's negative 1 because this right there is a negative 1. The degree is 4, which makes it quartic. And there's 3 terms, so it is a trinomial. Okay. Number 10 is a no. And you don't have to do any of this. No negative exponents. Number 14 is a yes. It is not in descending order, so this needs to move to the front, which right away gives me a 10 right here for the lead coefficient. Then the 4th power, then the 2nd power, and then the 8th. The degree is 5. The type of function is quintic, however you want to pronounce it. And once we go past 3, we just call it a polynomial. Number 15 is a no, right there. No fractional exponents. Not allowed. All right, these two are dividing. We're basically dividing each term by 4x. Okay, so remember, you could write these separately, 16x cubed over 4x minus 12x squared over 4x and so forth. But we're basically just dividing each term. So we're going to divide each number, 16 divided by 4, and then x cubed divided by x to the 1. Remember, we just subtract the exponents. Negative 12 divided by 4 is negative 3. 2 minus 1 is 1. 20 divided by 4 is positive 5. The x's cancel. And negative 8 divided by 4, careful with this one. The negative 8 divided by 4 is 2. The x stays on the bottom. Okay, it's not negative 2x. Negative 2x would be negative 8x divided by 4. That would be negative 2x. The x stays on the bottom. This is negative 8 over 4x. When these cancel to give you negative 2, the x stays on the bottom. Final answer. All right, 17, each term divided by 35 divided by 5 is 7. 4 minus 2 is 2. Negative 20 divided by 5 is negative 4. 3 minus 2 is 1. 10 divided by 5 is 2. The x squareds cancel. And again, just like the last one, the negative 40 divided by 5 is negative 8, but the x squared is on the bottom in the denominator. Final answer. Most common mistake is going to say negative 8x squared. Just telling you that right now. Please don't make that mistake. All right, direct substitution. That literally means take this 4 and plug it in here, here, and here. Okay? The long way of doing that is 2 times 4 cubed minus 5 times 4 squared minus 20 times 4 plus 52. So that gives us 2 times 64 minus 5 times 16 minus 80 plus 52. That's 128 minus 80 again plus 52, which gives us 20. Negative 1, we're going to plug in here and here. Now, the shortcut to this that we could have done number 18 is just go to our calculator and go to y equals, clear out whatever's in there, and put whatever you have. So in this case, x to the third power plus 9x minus 15. And go to our table and just look for negative 1. It's right there, negative 25. All right, much faster, much easier. Now, I would maybe suggest write this first line, just show the work you're doing, but then put it in the calculator if you want to save time. Or even if you just show this and say calculator, that's how you show your work. All right, divide using synthetic division. Remember, these are two different ways of showing synthetic division. Okay, they're both showing divide. So in this case, x plus 3, remember, I don't know what's happening here. We set it equal to 0 and find out that x is negative 3. That's the number that goes in the box. Now remember, my lead exponent is 3. So I look for a 3, a 2, a 1. I don't have an x, so I really have 0x there, and then I have my constant. So when I'm doing my coefficients, it's 1 for the x cubed, 10 for the x squared, 9 for the x. Oh wait, I do. Sorry, my bad. I don't know what happened there. My brain just kind of shut off for a little bit. I do have the x. It's right there. So I have no need for zeros here. And then my constant, negative 47. Now it's simple. You drop down the 1 and take this and multiply. And get negative 3. You add straight down and you multiply and get negative 21. You add straight down and get negative 12. You multiply by negative 3 and get 36. Add straight down and you get negative 11. we're done. We started with x cubed, so the 1 becomes the coefficient of x squared. The 7 is the coefficient of x. The negative 12 is my constant. And then we just put the 11 over my original divisor of x plus 3. That's it. Over here, we're doing x minus 5 equals 0. Okay. X is 5. That's the number that goes in the box. Now, looking at my exponents, I have a 3, I have a 2. This time I don't have a 1, so I'm going to have a 0. So it's 3, negative 14, 0, negative 29. Drop the 3, multiply by 5. Add straight down, multiply by 5. Add straight down, multiply by 5. Add straight down. I started with x cubed, so my answer here is going to start with x squared. Then x, then a constant, and then 4 over my original divisor of x minus 5. That's my answer. Okay, evaluate with synthetic division. Synthetic substitution. Please remember, do not put negative 4 in the box. I am telling you this is the number that goes in the box. Okay, so we don't set it equal to 0 or like up here and think, oh, it's negative 3. Oh, it's positive 5. I'm telling you it's 4. All right, we have a 3, we have a 2, we have a 1, and we have a 0 constant. So I don't need any zeros in my setup. Drop the 2, multiply by 4. Add straight down. Multiply by 2, add straight down. Sorry. Multiply by 4, not 2. Silly me. 4 times 3 is 12. Add straight down. Multiply by 4. Add straight down. I started with cubed, so it's going to be 2x squared plus 3x minus 8 as my constant plus my remainder over my original divisor. Now here's where we got to think. If x equals 4, let's just move the 4 back over. That means x minus 4 equals 0. So my original divisor is x minus 4. But when we're doing these problems, we're actually only looking for this number. Okay? The answer is 20. We don't have to do all this. I just wanted to show you this reminder here. But when we do that, we're just looking for the remainder. So on this one, again, negative 1 goes in the box. I have a 3. I don't have a 2. I have a 1. And I have my constant. Drop the 1, multiply. Add straight down. Multiply. Add straight down. Multiply. And I'm actually done. If I put in negative 1, I get negative 25. This is another way to write it. Okay, so this one is a combination of the two above. So again, this is the number that goes in the box. I look here, I have 3, 2, 1, 0. So it's 1, negative 5, negative 9, 45. Our goal here is to get a 0. If we get a 0 there, that means it is a factor. If we get a remainder, it's not. So we drop the 1, multiply, add straight down, multiply by 3, add straight down, multiply by 3, add straight down. Yes, x equals 3, or x minus 3 is a factor. Over here, again, we have to set this equal to 0. So x equals 1. So 1 goes in the box. I have a 3, I have a 2, I have a 1, I have a none, so I don't need any zeros. So it goes 3, 6, negative 7, 2. Again, we're looking here for a 0. Don't know what happened there. So we drop the 3, multiply, add straight down, multiply by 1, add straight down, multiply, and we get 4. Since we have a remainder, the answer is no. X minus 1 is not a factor. All right, now we're going to factor these. Always look for a GCF first. All right, so all these numbers and right here are all perfect cubes. So we're doing SOAP. So the cube root of 27 is 3. The cube root of x cubed is x. And the cube root of 64 is 4. Okay? Not putting the signs in until the end. So we square the first term. We multiply the 2. And we square the last term. Now, SOAP. This was subtraction. Same. Opposite. Always positive. And we're actually done. That's it. Whoops. All right, over here, this factors just like this. Okay, the only difference is we have a 4 instead of a 2. But look here, if we factor this, we're looking for two numbers that multiply give us 54 that differ by 3, which is 9 and 6. We want more negatives than positives. That's it. This factors the exact same way. The only difference is instead of x to the 1 times x to the 1, it's x squared times x squared. Otherwise, it is exactly the same math. Then we have to go one step further, because that's the difference of squares. And this breaks down to x plus 3, x minus 3, if I could actually write a minus. Remember, we always want to ask, can I go further? And for this case, if this happened to be like a 16, okay, or a 9, a perfect square, 25, I could have factored it to x minus, let's say it was 25, x minus 5i, x plus 5i. But we stop. That's it. All right, we have 4 terms here, so we're going to factor by grouping. So what can I take out of x cubed plus 4x squared? I can take out an x squared. That gives me x plus 4. Now the cool thing about this method is I can go over here and kind of cheat and write x plus 4. I know what they have to match. Now I can just ask, this divided by what gives me this? Well, 5 divided by 5 gives me x. And 20 divided by 5 is 4. Almost done. Hook those two up. Write this one. And that's it. Perfect cubes again. Happens to be a plus this time. So cube root of 125 is 5. Cube root of x cubed. Cube root of 343 is 7. Square the first term. Multiply them. Square the last term. Now go in and do SOAP. Same, opposite, always positive. All right, here we have 2 perfect squares. So this is a difference of squares. That's it. Square root of the first. This happens to be x squared this time. Square root of the second. 1 plus, 1 minus. Now, we have a sum of squares and a difference of squares. So this breaks down to 2x plus 3, 2x minus 3, almost. If we did that, we would get this. So to make this plus, we need to add I. And like I said, this ends up being 2x plus 3, 2x minus 3. And that's it. Number 31, again, we're going to do factor by grouping. So I can't take a number out, but I can take out an x squared. So that's going to give me 3x minus 4. I know I need 3x minus 4 right here, so I already fill it in. And I just ask myself, what do I need to divide this by to get this? -1. Hook these two up. X squared minus 1, which is a difference of squares, times 3x minus 4. We always ask ourselves, can I do anything more? This breaks down to x plus 1, x minus 1, times 3x minus 4. And that's it on that page. And that's it for the review.